Hello, welcome to our webinar today. This is Naim Kenan Hacevliyagil from FabMetrics, and with Saygın and Merve, today we will talk about predictive maintenance, especially anomaly detection implementation over two different services, which is AWS Lookout for Equipment and EFPF anomaly detection. So let's Saygın to introduce himself and his department. Saygın.
Well, hello everyone. Welcome to our webinar for today. My name is Saygın Kaçar. I am the Smart Production Technologies Manager in Borcelik. So what we do in our department, we are seeking for the solutions to the problems at the field area by new technologies here. And Merve?
Hello everyone, welcome to our webinar. I'm Merve. I'm a data engineer in Borcelik. I'm also a PhD candidate in Management Information Systems program. Thank you.
Thank you, Merve. If you want, let's do a webinar like that, introducing the companies. So let's start with FabMetrics then we will go through Borcelik. So as FabMetrics is a software solution indeed, and it is developed to give access to any size of manufacturing companies into the Industry 4.0 technologies. Our main focus are in the industrial IoT, big data analytics, machine learning, and cloud computing. And with FabMetrics, we provide solutions mainly to two users. At one hand, manufacturers. On the other hand, we are offering our solutions to machine builders and OEM industries. So if we go into the details of FabMetrics solutions, on one hand, we have factory solutions. So in the factory area, at the manufacturing area, we make every production asset connected, and by collecting data of these production assets from machines to quality control points, we create a digital shadow of the production plant. And on the other hand, with this IoT data, we convert IoT data to insights and value by using AI algorithms. It is indeed one of the topics of today. That was our factor solutions. On the other hand, for machine builders and for OEMs, we also provide FabMetrics platform, on which machine builders can offer digital services that I mentioned for the factories with their white label. That can be a customized MES or industrial IoT platform, or they can use also the platform for the monitoring of their products on the field. Next to these two product solutions, we also give customized AI model development services for manufacturing and machinery companies as well. And our specializations are adaptive processes, predictive maintenance, predictive quality. Besides this, we also do manufacturing data analysis and visualization. So indeed, we do all these services and solutions over 4 products, which is FabMetrics MES, FabMetrics Gateway, FabMetrics AI, and FabMetrics Insight. And today we will mostly focus on FabMetrics Insight solution and FabMetrics AI solution. So let's Saygın to introduce a little bit about Borcelik.
Okay, thank you, Kenan. Borcelik is a flat steel producer in Turkey, and it's been sustaining its activities since 1994. Borcelik is a joint venture of Borusan Group in Turkey and ArcelorMittal. So we got a video of Borcelik, which will explain better.
We have a story. A story of feeling proud of what we evoke in people's minds when it comes to us, benefiting our industry, society, country, and the world, enlightening the future. The story of Borcelik. you are fully committed to a story with all your strength, courage, determination, and energy, and if you have built experience and solid trust across your stakeholders, you take your steps in this story through respect for your job and values, and through technology and science-driven research, development, and learning. We take our steps in this story by meticulously working with utmost awareness of our duties and willingness, always aiming to achieve the better and become excellent, topping up each and every achievement attained with further achievements through efforts, determination, and stability in order to fulfill our duties towards the story with a dynamic team of knowledgeable and well-experienced colleagues with adaptness in their job. We have a story of enlightening the future achievement. The story of Borcelik.
Okay. We also have a R&D department in Borcelik. We are mainly focusing on three things in our R&D department. First of all, material. Our material development division is mainly focusing on the activities for transition from commercial products to high added value products. Secondly, process development we are focusing on with the intention of the development in our company of exogenous process technologies we are dealing with. And also the last, the technology development division, which we are in with Merve, for the sake of adaptation of current technologies to our existing processes by following the existing trends. Now Merve can just explain what our motivation was for this application. Merve?
All right. Now I will talk a little about what our aim was in the first place. As Borcelik, we have a large production facility. Within this area, we have so many assets. Here, we monitor the condition of assets using sensors such as temperature, vibration, acceleration, and current. In the figure, you can see our digital platform. With the help of this platform, we do not only observe the condition of the assets, but also can reach the historical data. Here we have an example of output of our system. For instance, in this figure, we have a scale breaker asset, and it is equipped with these sensors. We can easily understand by only looking. We can easily understand the condition of the assets by only looking at its color codes. Even though we obtain big data, our platform doesn't have a predictive maintenance layer. Using this data, we would like to predict possible malfunctions on critical assets. It will be instrumental for us to reduce downtime, avoid unplanned stoppages, decrease quality problems, and increase safety in the working environment. With this motivation, we started our project. Now, Kenan will explain our pilot study.
Okay, indeed, the pilot we did is on continuous galvanization line of Borcelik, as you can see in here. As the video on the video underlined, Borcelik is the biggest galvanized manufacturer of Turkey, and this line has indeed lots of motors and fans and pumps. So in this case, we make all these motors and fans are connected over condition monitoring sensors, and we 43 different equipments on this line is connected to our system, and they sent us 332 data tags indeed, and 21 different equipments are coming to us. And if we are talking about the connectivity of the line, the systems that are connected can be a fan or pump. And fan or pump doesn't matter. We have that kind of system. So we have motor in this side, and on that side we have pump or fan. And of course, these systems are driven by an PLC. And as you see at motor non-drive end and drive end, we have two sensors. On the other hand, at pump or fan drive end and non-drive end, we have another sensor. And these vibration sensors are sending us these data, so velocity, acceleration, misalignment, looseness, bearing, and unbalance. Indeed, velocity is our main data about vibration, and these others are the analyzer output of this. So per sensor, we have 6 different data feature, and next to it, we have also RPM and start-stop data of the line. So with this structure, indeed, we set up an experiment just to see different anomaly services and how it will help to Borcelik's uptime. So for this webinar, we will just go through with one of the systems, which is indeed called CGL1. It is the name of the line, and 300 ACM02. Indeed, it is NOF exhaust fan application. And in here, we have 4 different sensors at fan drive end, fan non-drive end, motor drive end, motor non-drive end. These are the names of the sensors that you will see on the demo system in a few minutes. So with these sensors, what we did is we took last year's first half data as training data, and then we estimate from beginning of this year till the 5th of May, and we trained this model with these 24 features. As I explained, there were 4 sites and 6 text. So at the end, we have 24 different features. And as you see, training period is here and estimation period is here. And the anomaly output, as you will see in the system, is called like this tag. And with this anomaly output, the system for estimation period analyzed 33 different anomalies. And when we go into these anomalies, mostly they were observed in January, and you will see it also on the demo site. It was determined that they were like bearing failure signals indeed. Saigon will explain you in a few minutes more. And if you look to these anomalies from data perspective, the detected anomalies on January are seen like this. And if we look them from higher time horizon, they are catch like this. And this is our view from data perspective. And let Saigon say something about these anomalies from operational perspective.
Sure. After getting this actually anomaly detection in our site in Borcelik, our maintenance team also took a look at the system. So they just found out that there was a problem with the bearing of the motor. I mean, the motor itself was just about to create a kind of malfunction and stop the line.
Thank you, Saigon, for information. So if we continue with the benchmarking of anomaly detection services, so let's see firstly in terms of the elements. So on one hand, we have AWS lookout for equipment. On the other hand, we have EFPF anomaly detection. So in terms of model selection, indeed for AWS lookout for equipment, you cannot select a model. It selects its own model automatically. On the other hand, at EFPF, there are 4 fixed models, and as user you can select which model you want to use for anomaly detection. And in terms of training, if you want to train a model at eFPF service, you should do it by uploading a file. But at AWS side, there is automation that you can do it over API. Of course, it is also possible to do it over console, but you can, since it has APIs, you can easily integrate training process to any application you have. And in terms of running, these two services differ from each other. At eFPF side, it is continuous running. So every data coming is sent to the model over MQTT, and the coming data is analyzed, and the model says you back if it is okay or not okay, if there's an anomaly or not. On the other hand, at AWS, it is more designed on scheduled running. What we mean by scheduled running, it is not you streaming data continuously. You make a batch, then you send this batch, and for this batch, it gives you feedback if it is okay or not okay. I mean, if it is anomaly or not anomaly. So, and as user, you can also decide the how do you say, the batch size. It means that the frequency of analysis. So I will show it also on the demo that you can select the inference schedules period there. So in that sense, it is also possible to integrate this scheduled running to any third-party system or its APIs. So if you look to the process, it is like that. I'm talking about AWS Lookout for equipment. As an end user, you generate AI agents in the system. So as you create an AI agent, firstly you train it with a time frame. Then after it is trained, it ingests data, and in the system, indeed it takes data from NoSQL to file, and this file is uploaded to system and ingested by the AWS service, and there they check the compliance of the data, and if there is no problem with data, then the system sends you to a message that the model is ready to live, and it means that the model is trained and you can take it to operation. And as a user, as I explained at the previous slide, you decide the frequency of the analysis and you make live the system. On the other hand, at eFPF anomaly detection service, it is not possible to integrate all this workflow to your third party because there is no SDK. So as an end user, you cannot create your AI agent over any other system. So you should do all these things over the interface of eFPF, and there is also no compliance control kind of steps at eFPF. So on the other hand, at AWS side, you can have all data, but at eFPF interface, you can see anomalies only for 1 week. So if we compare these two services in terms of ease to use, let's see how you feed the services. So both are receive the data over CSV files, and how we give this CSV file. At AWS, you leave it to S3 service of AWS. On eFPF, you upload the CSV manually to the over the interface of eFPF. And to get data from the model, again, you do it over S3 on AWS, but at eFPF, the outputs are sent to you over MQTT or AMQP on your selection. And you can create some rules when you upload the data in it at AWS, but it is not possible with eFPF. And the algorithms behind AWS is unknown, so they don't give you much details. But at eFPF, the algorithms running at the backgrounds are open to public. So as it is open to public and you select single algorithm from their database, their offerings, they have 4 offerings. And on the other hand, at AWS, you cannot select your algorithm, so it decides its own structure and gives you outputs. As I underlined at the previous slide, AWS software development kit. At eFPF, you don't have it. And as I underlined at the previous slide, it is possible to create your AI agent with AWS. And also scheduled time analysis is possible with AWS, but real-time analysis is possible with eFPF. Another thing is at AWS, as I showed you, we have 24 different features. If you want to train a model at AWS, every tag you can give separately to the model, but at eFPF's side, you should combine all these 24 features in one single CSV. So you should prepare the data, then this single file should be uploaded to eFPF. So that was the ease of the use. And in terms of the flow, if you want to see, at eFPF, you have at local CSV file that you combined all different sensors in one file. Then you send it to eFPF service over its interface, and you train the model with the CSV file. Then after train, the results for test and run are sent over MQTT or AMQP, and the results of test is given to you as a CSV file at the eFPF interface face. And when the model is run, again, the solutions, the results are sent to you over MQTT or AMQP. And in that way, our eFPF interface, the user can see the results. On the other hand, at AWS Lookout for Equipment, you should put the files on S3 service of AWS. And the models read the CSV files from here, and train and test operation is continuously going on in the Lookout for Equipment service. When training and testing ended, the test results are sent as JSON file, and when the model is ready to run, when you run, also the outputs of the Anomaly service are also written you as a JSON file, and these JSON files are sent to S3 bucket of AWS. And if you want to show these results on your interface, you can easily take these files, write on your DB, or just show on your interface. So we will go more in detail of the outputs of these services, but as you see on the screen, the Anomaly outputs of sensors are seen like this graphically on the system. So let's go to more into the detail of the this experiment over the demo that we created on FabMetrics. So as we underlined, the machine is 300 AC M02, and the AI agents will be this one. So let me go to, okay. So now we are on the system indeed. So right now you see the system. In here, this is the FabMetrics dashboard indeed. At dashboard, you see the continuous galvanization line, and some data from this line is coming to our dashboard, as you can see in here. So every asset that we have mentioned during the presentation is here on our asset list, which is coming now. Yeah, you see our Borcelik factory and continuous galvanization line, and all our assets are underneath it. If you want, let's see it from this view. So what we are talking about is NOF system, which has 300 ACM02. As you see, these 4 sensors are in here: fan dry vent, fan non-dry vent, motor non-dry vent, motor dry vent. And if you go in detail, you see the 6 sensors: acceleration, bearing, looseness, misalignment, unbalance, and velocity for each sensor. Let's go to velocity, for instance, for that case. So we see the velocity data like this on the system. So based on this data, indeed, you see all this data, we use these 24 different features for our AI model. So we will see our AI models in here on our manufacturing process model library part. As I underlined during the presentation, we have predictive maintenance models, predictive quality, and adaptive process models. Right now, we are talking about predictive maintenance. So in here, anomaly detection models, you will find this pillar. Next to anomaly detection models, we have also condition change detection and remaining lifetime calculator models as well. But today we will mostly talk about this anomaly detection tool. So this pillar you see is AI model group indeed, and every box you see is an AI agent. So right now you see we have 2 different models. One of them is for 300 ACM02, the other is for another motor. So that model has been already configured. As you can see, all these 24 sensors are added for this system 300 ACM02. So all its 24 sensor data is added, and training period and estimation periods are also added. And this data has been sent, and the output of this service, this anomaly service, will be like this. And this service indeed trained and tested, and it is ready to live. As I explained during the presentation, it is possible to make live and select the data frequency. So in which time frame the system will analyze the batch of data. So it is possible to make it over here and by selecting an expiration date. So let's see the outputs of this anomaly model. It is here, as you can see. This is the output of the anomaly model. So as we did an analysis from January till May, let's have the starting time as January. And so now we will see our outputs. So we underlined that there were anomalies identified in April, but also mostly in January that Saigon has talked and underlined. It was around bearing issue. So as you see, the system started to detect its first anomaly over 11 January. And in here you see a long list. Indeed, this list gives us the contribution of each sensor to this anomaly. So that gives also us an understanding about the root cause of the problem. So as you see, this is our anomaly output, and the anomaly continues till 15, and then also 16, 17, and 19, and till March and April, we don't see any other anomaly. And as Saigon underlined, this layering problem is solved, then the system gets stable. So that's all indeed I can show you about this anomaly detection, and how we represent it here is like this. We have these sensor data, as you see. So every sensor we have 6 data, and the anomaly detections are defined in here as another asset. And these assets or any AI algorithm data can be reached over this representation as well. So in terms of anomaly detection, that's all I can tell you about solutions. Other solutions, condition change detection, remaining lifetime calculator. I can give you just brief idea. Condition change detection is like that. If this is implemented per one sensor data, and if there is a change in the behavior or the regime of the sensor data, then that sends you a notification. So if there is a condition change, if there is a drift in the data, it warns the end user. On the other hand, remaining lifetime calculator is like this. Imagine I will show you over representation. Imagine you have a sensor data and these are your thresholds. Remaining lifetime calculator gives you how many hours left to reach any threshold in here. Indeed, if you want to see it over real case, we can do it over 300 ACM data velocity, non-dry events. Yeah. Yeah, as you see, for these thresholds, it calculates how many hours left for this data. So the thing that you see in here visually, indeed in our manufacturing library as an AI agent, it is like this. And when you configure your sensor data and your thresholds as well and your model settings, then the system continuously calculates this remaining lifetime and sends you the how many hours left for this threshold. So this is all from our side. And thanks for your time, for listening our presentation, and hope to see you at the next presentations about digging more into the details of other predictive maintenance models of FabMetrics and also applications at Borcelik site. Thank you for your time.
Thank you.
Thank you.